Hi guys, and welcome back to another episode of Physics in 5. Today we are covering the principle of superposition, and later today we're going to be covering wave-particle duality of light, which is something I promised to do in the first episode, but we need to do this first, so let's get cracked on. So on the board we have a wave, a rough diagram of a wave, and let's assume that it's all the same, it just repeats. And when we look at a wave, we have the equilibrium line, the zero line, through the middle of the wave. And the difference between the zero line and the peaks, or the troughs, we call the amplitude A. And when we talk about a wave, we describe the motion of the wave, which is this, as a function of the time in which the wave happens. So we have the amplitude A times the sine wave, because it follows the same pattern as a sine wave. Sine wave is a function of the frequency and the time, plus this symbol here. And this is the Greek letter phi, which is the term we use to mean phase difference. Now, the phase difference here, let's say this is 0. If we shift the phase difference of the wave to here, then the wave is still the same. It's exactly the same. It's just constantly half a phase difference out every time. Those two waves, give or take my bad drawing, are exactly the same, and this is just a phase difference of a half. This is really important when we're talking about superposition and waves interacting with each other. Now, when we talk about waves interacting, it's quite easy to think of, say, a wave on a piece of string, or a sound wave, or something similar. So let's say we've got two sound waves here of exactly the same. Now, if we have somebody stood here on both waves, then they're going to hear 2 times the sound. But if we take somebody stood here, they're not going to hear anything. Now, if we had another wave, this time entirely out of phase with the first blue wave, what we end up is with the positive amplitudes and the negative amplitudes of the wave adding together to give absolutely 0. So again, somebody stood here would hear absolutely nothing, because the two waves perfectly cancel each other out. The amplitudes, when everything about the wave is the same, the amplitudes simply add together. So a positive amplitude and a negative amplitude will cancel each other out. It's really important for me to add here, guys, that these waves are supposed to be on top of each other. So when I draw the x's, I'm talking about a place along the dotted line. Equally, 2 positive or 2 negative amplitudes will add together. So what we'd end up with here is just a straight cancel of the two, and what we end up here is an exact double of the two. Okay? That is the principle of superposition. It is important to say here, guys, that these two waves must be of the same kind. So it can't be a light wave and a sound wave interacting, for example. And it's also important to say that after the two waves interact in such a fashion, they carry on as they were. So if, for example, the two waves were crossed, the point in the middle would be where the interference occurs, but the point in the travelling direction for both waves, the wave returns exactly the same. The waves are unaffected after the interference point. Interference, where the two waves cancel each other out, destructive interference, and when they add together, constructive interference. So we can see here clearly, as I've been saying, the waves, when they're in phase with each other, their amplitudes add, and when they're exactly 180 degrees or pi radians out of phase, then they completely cancel each other out. But what we do find is that when the two waves have different frequencies and different amplitudes, is that as long as they're still from the same medium, as in sound wave or light wave or other electromagnetic radiation, or a wave in the ocean or a wave on a string, for example, their amplitudes still add together to give a bizarre resultant wave. That can be explained if you stand in a concert hall, for example, and you're at an odd angle to different instruments, you'll hear slightly different sound to somebody who's sat on the opposite side of the room. Okay guys, so thanks for watching this video on the principle of superposition. I hope it really helped. If you haven't already, hit like on the video, subscribe for some more, check me out on Facebook and check me out on Twitter, and again, thanks for watching and I'll be back shortly.